Welcome to the UAV Hallway Blocking Project by David, Eric, and John. Our project automates a UAV to block crowds coming down a hallway from crossing a line in which it operates, as well as allowing manual control of one of the crowds in order to observe particular behaviors of the automation. To do this, we chose the UAV as the frame of reference. For crowd detection, with the sensor on the UAV, this is already the case. The localization sensor, however, needs to be transformed to be egocentric, and in turn make percepts of the walls. Our motor schema are all exponential potential fields across some configured area. They're perpendicular, attractive, or repulsive around a point, or random 2D for intervals. Our design uses a combination of subsumption and potential fields, with one tactical avoid behavior. This behavior adds repulsive fields perpendicular to walls, and from the surface of crowds, which is a shallow but strong field, to avoid having the UAV knocked out of service entirely if the crowd is stubborn. The first layer, watching, is active if no other layer is. Then, two behaviors are active. The first, keep height, uses motor schema to generate opposing fields from the floor and ceiling percepts to maintain a height above eye level. Meanwhile, a point attractive field relative to the walls centers the UAV in the hallway. The approaching layer may be released at any time, subsuming the output with two different behaviors, another keep height behavior, this one configured for eye level, and a behavior to follow the crowd by being attracted to its percept location. Note that the point of attraction is usually out of the UAV's operating plane. For this reason, the motor schema only enables its x-dimension component of output. If any sensed crowd is within the threaten range parameter, then the third layer is released and subsumes both other layers' output. In this case, we have a chest-high keep height behavior, a follow as in approaching, as well as a random 2D behavior, which generates a random potential field in the plane. This field is scaled to be strongest while directly in front of the crowd to allow follow to dominate while getting into that position.
We tested using a basic verification and validation method. We also ran the simulation exhaustively to find incorrect behaviors and testing the limits and scope of relevant variables.